Hello again, my fellow pilots and aircraft maintenance personnel. Your host is always Haytham Aly, and I'm an aviation technical instructor. Welcome to my aviation nuggets for today. Today you will join me in an interesting quiz to recall and to refresh your knowledge regarding the Airbus A320 ice and rain protection system. You will join me today to have a quiz on the Airbus A320 Chapter 30 Ice and Rain Protection System. Okay, so let's join me. Let's join the quiz now. Haytham Aly. And let's have our quiz now on the Ice and Rain Protection System for the Airbus A320. Okay. So, first question. True or false? For anti-icing, hot air or electrical heating, protect the critical areas of the aircraft. Yes. This statement is very true. For the Airbus A320, some location do need hot bleed air for anti-icing, like the engine air intake cowl or the wing anti-ice. The three outboard slats. Slat number 3, 4, and 5 need hot bleed air. Okay, other areas, other location need electrical power or have electrical heating to protect this area from anti-icing. What are these locations? The windshield for the captain and first officer, windshield electrical heating, the drain mast electrical heating, drain mast forward, drain mast, and aft drain mast. Also the probe and sensor ice protection system, BTOT static, TAD probe, and angle of attack sensor also need electrical heating to protect this area from ice accumulation, from ice anti-accumulation. So again, for anti-icing hot air or electrical heating, protect critical area of the aircraft. Yes, this statement is very true. Okay. Next question. For wing anti-ice in the A320 family, hot bleed air is used, electrical heating is used, or both are used, hot bleed air and electrical heating, Okay, for wing anti-ice, hot bleed air is used. For wing anti-ice, hot bleed air is used. And remember, for each wing, there is a wing anti-ice valve. For each wing, there is one wing anti-ice valve. And one push-button switch in the overhead anti-ice panel, wing anti-ice, one push-button switch or one switch for both wings to have anti-ice for both wings. Okay, so what location exactly have hot bleed air for wing anti-ice? The three outboard slats. Slat number 3, slat number 4, and slat number 5. Okay, everybody. Let's proceed. Next question. Question 3 of 24. For anti-icing, hot bleed air is being used for. For anti-icing, hot bleed air is being used for engine air intake and wing anti-ice, drain mast heating, probes and sensors heating. Okay, so the right answer is engine air intake and wing anti-ice. For anti-icing, hot bleed air is being used for engine air intake cowl. You remember each engine from the high pressure compressor of that engine supply its engine air intake cowl with hot bleed air, Okay, and the bleed system from any engine, okay, can supply the wing anti-ice, the three outboard slats of each wing. For each engine, we have one push-button switch in the overhead anti-ice panel. And for the wing anti-ice, we have only one push-button switch for both wing. And the hot bleed air goes through a wing anti-ice valve. For each wing, there is one wing anti-ice valve. For wing anti-ice, we can select wing anti-ice in flight, and only the wing anti-ice valve will open on ground for 30 minutes. This is for maintenance task only. But for engine air intake, we can have engine air intake anti-ice on ground or in flight. On ground or in flight. Okay, everybody. Okay. Let's proceed. Next question. Hot air from the pneumatic system is supplied for the anti-icing of the two outboard leading edge slats. Two outboard leading edge slats. This statement is false. Hot bleed air is being used for the three outboard slats. Three outboard leading edge slats, not the two outboard leading edge slats. Three outboard leading edge slats. Okay. Next one. Question 5 of 24. There is only one wing anti-ice valve for both wings. Again, this statement is false. We have for each wing one anti-ice valve. One anti-ice valve. For each wing, there is one wing anti-ice valve located in the leading edge of the wing. This wing anti-ice valve will open with one switch for both wings. For both wings, we have only one wing anti-ice push button switch located on the overhead anti-ice panel. Okay, everybody. Next question. I hope you enjoy this quiz. There is only one wing anti-ice switch for both wings on the anti-ice panel. Again, there is only one wing anti-ice switch for both wings on the anti-ice panel. This statement is true. Yes. This is the overhead wing and overhead anti-ice panel. We have one switch for both wings. We have a switch for each engine air intake cowl anti-ice, and we have a probe window heat switch. And this switch have auto legend behind it, because probe and window heat starts automatically when at least one engine is running. Automatically when at least one engine is running. Okay, so this statement is true. Yes, there is only one wing anti-ice switch for both wings on the anti-ice panel. On the anti-ice panel. Okay. Let's proceed. Next question. True or false? A single push button switch on the overhead anti-ice panel control wing anti-ice supply to both wings. Yes, this statement is true. We have only single push button switch. Okay, we have only one push button switch to select wing anti-ice for both wings. For both wings. Okay, so this is the location of the wing anti-ice valve. It is located in the leading edge of the wing. Okay, control the supply of hot bleed air to the three outboard slats. Okay, in case of selection of the wing anti-ice, as you can see here, the air conditioning system controller, this is the enhanced, in the enhanced Airbus A320, the air conditioning system controller, ask the engine interface unit to ask the FADIC or the engine computer to increase the engine idle setting or decrease the engine toga setting to accumulate or to allow the engine to understand that now wing anti-ice is being used. Now wing anti-ice is being used. Okay, so this statement is true. Yes, we have a single push button switch on the overhead anti-ice panel controls wing anti-ice supply to both wings. Okay, let's proceed. Next one. I hope you enjoy these questions with me. Question 8 of 24. Wing anti-ice must be automatically done when one engine is running, manually selected by the crew. Yes, wing anti-ice must be manually selected by the crew. The switch for wing anti-ice has no auto legend behind it. This meant that pilot or flight crew must manually select wing anti-ice, and it can be done only in flight. Only for maintenance purposes on ground, the wing anti-ice valve can be opened for 30 seconds only for test purpose. If the wing anti-ice selected on ground, the wing anti-ice valve will open. Yes, it will be open, but only for 30 seconds. But only for 30 seconds. 30 seconds. Okay. So again, wing anti-ice must be manually selected by the crew. Manually selected by the crew. And only one single push button switch for wing anti-ice. Supply wing anti-ice for both wings. Supply wing anti-ice for both wings. Okay, next one. Next question. Question 9 of 24. What is the interface concentrator between engine computer and airframe computer? It is the FADIC Full Authority Digital Engine Control. Is it engine interface unit? Is it air conditioning system controller? The interface concentrator here is the engine interface unit. Engine interface unit. As you can see from this schematic, when you select wing anti-ice from here, the air conditioning system controller will ask the engine to control the engine idle setting or engine toga setting to accumulate or to allow the engine to understand that wing anti-ice now is being selected. So we need a certain pressure from the engine high pressure compressor. So what is the concentrator between the air conditioning system controller and the engine controller? It is the EIU, engine interface unit. For each engine we have one interface concentrator located in the avionics compartment. Its job to be an interface concentrator between airframe computer and the engine computer. What is the engine computer? It may be EEC or ECU, as if it is a V2500 engine or CFM56 engine. Okay. Next question. Next one, question 10 of 24. Each engine air intake is protected from ice by an independent air bleed supply from the high pressure compressor. Yes, this statement is very true. Each engine supply its engine air intake with hot bleed air. Okay, it's not like the wing anti-ice. In case of wing anti-ice, any bleed source like engine 1 or engine 2 can supply both wing. But for the engine air intake, each engine supply its own air intake cowl by an engine anti-ice valve. So this statement is true. Each engine air intake is protected from ice by an independent air bleed supply from the high pressure compressor of that engine. Yes, this statement is very true. Okay. Next question. Question 11 of 24. Each engine air intake is protected from ice by an independent air bleed supply from the high pressure compressor of that engine. From the high pressure compressor of the APU bleed only, of any engine, of the same engine. The right answer is of the same engine. Yes, of the same engine. Again, each engine air intake is protected from ice by an independent air bleed supply from the high pressure compressor of the same engine. We need to focus on this idea. Each engine supply its own air intake cowl. You cannot have engine 2 supply air intake cowl of engine 1 or vice versa through the bleed system. No. Each engine will supply its own air intake cowl. So each engine air intake is protected from ice by an independent air bleed supply from the high pressure compressor of the same engine. Okay. Let's proceed. Next question, everybody. Engine anti-ice is manually selected by the crew and is available in flight or on the ground with the engine running? Yes. This statement is true. This statement is very true. Yes. So, each engine from its high pressure compressor through an engine anti-ice valve, engine air intake anti-ice valve, supply its own air intake cowl. Supply its own air intake cowl. And same. The air conditioning system controller here in the enhanced A320 ask the engine computer, FADIC, through the engine interface unit to adjust the engine idle setting if it was selected, or adjust the engine toga setting if it was selected, to accumulate for engine air intake anti-ice. And also, when you select the engine air intake anti-ice, the FADIC will do continuous ignition on the selected engine, air intake anti-ice. Continuous ignition will happen. Both igniter will come to accumulate for bleeding air from the high pressure compressor of the engine. We are afraid that the engine will shut down because we add extra user on the engine. We take air from the engine. So when engine anti-ice is selected, engine air intake anti-ice selected, the air conditioning system controller here will ask the FADIC to do continuous ignition and to adjust the idle setting or toga setting to accumulate for engine air intake being selected. Okay. Next question. Question 13 of 24. In the event of an electrical power supply failure, the engine anti-ice valve will automatically closed when the engine is running, open when the engine is running, closed when the engine is stopped. The right answer is open when the engine is running. Open when the engine is running. The fail-safe design for the engine air intake anti-ice valve is open. If electrical power fail, this engine air intake anti-ice valve will stay open, fail-safe open, if electrical source is lost, as long as the engine is still running. So the benefit behind this question is to understand that the fail-safe design of the engine air intake anti-ice valve is open when engine is running, when there is pressure supply from the engine, there is an air supply of the engine. So from this question we understand that the fail-safe design for the engine air intake anti-ice valve is open. The fail-safe design of the engine air intake anti-ice valve is open when the engine is running. Okay, everybody, very good. Let's proceed for the next question. Question 14 of 24. Ice protection of the angle of attack sensor, BTOD probe, static ports, and the total air temperature probes. Electrical heating. Is hot air heated or both of the above? The right answer is electrical heating for the probes and sensors. BTOD, static, angle of attack sensor, and the TAT sensor, we use electrical heating. We have 3 sets of these sensors: pilot sets, first officer set, and standby. So we have 3 probe heat computer: BHC1, BHC2, and BHC3 for BTOD and static sensor heating, or probes heating. So what is this picture? We have here the 2 optional ice detector, electronic ice detector. They are based on the vibrating rod philosophy. They are optional, not basic. Okay. Next question. Question 15 of 24. In order to give reliable information to the air data systems, the air data probes are heated automatically when at least one engine is running, or manually when both engine is running. The probe window heat switch here have an auto legend behind it. So probes are automatically heated when at least one engine is running. Again, probes are automatically heated when at least one engine is running. And as you can see here, we have 3 probe heat computer. 3 probe heat computer. Why we have 3? Because we have 3 channels for the probes. Captain channel, first officer channel, and standby. We have certain probes for the captain side, certain probes for the first officer side, and other standby probes, The probe heat computer always needs signal from the LGCIU, as you can see here, because they need to know if the aircraft on ground or in flight. Because like the TAT sensor, they are not heated on ground, they are heated only in flight. TAT sensor. Okay. And the probe heat computer also needs signal from the engine interface unit to know that one engine is running, because the probe is automatically, the probes are automatically heated when at least one engine is running. From where the probe heat computer will know that one engine is running? From the engine interface unit. We have a heater in each probe or sensor, as you can see here, and the probe heat computer controls the heating to the heater in the probes or sensor. We have here 28 volt DC and 115 volt DC. 28 volt DC for the probe heat computer power supply and for the static ports. The other port, angle of attack, BTOT, and the TAT have 115 volt AC. Okay, everybody, let's proceed for the next question. Question 16 of 24. The probes are arranged in 2 channels related to the 3 air data systems, captain, first officer, and standby. This statement is false. Because the probes are arranged in 3 channels, not 2 channels, 3 channels related to the 3 air data systems. We have 3 air data systems, so we'll have 3 channels for the probes, BTOT, static, angle of attack, and the TAT. We have captain channel, first officer channel, and standby channel. So as we have 3 probe heat computer. Okay, everybody. Next question. Question 17 of 24. How many probe heat computer in the A320 aircraft? We have 3 BHC, 3 probe heat computers. So the right answer is 3. So the heating to the probes and sensor are electrically controlled by 3 probe heat computers. BHC 1 for the captain, BHC 2, and BHC 3 for the first officer and standby. Okay, very good. Let's proceed. Question 18 of 24. How many window heat computer in the A320 aircraft? We have 2 window heat computer. Window heat computer number 1 for the captain side, windshield and side window, sliding and fixed window. And window heat computer number 2 for the first officer, windshield and side window. Okay, and same, the window heat window heating is done automatically when at least one engine is running. As you can see here, the probe window heat switch have an auto legend behind it. And same, the window heat computer need a signal from the engine interface unit to know if one engine is running or not yet. Okay. So let's proceed. Next question. Question 19 of 24. The windows are protected against overheat by sensors and flight ground logic. Flight ground logic. Yes, this statement is very true. We have temperature sensor in the windshield and side windows to control the heating for the window. If an overheat happen, the window heat computer will stop heating to the windshield and side window. And also we have flight ground logic because the windshield and side window have an electrical anti-icing by heating with low power on ground and high power in flight. Low power on ground and high power in flight. So this statement is very true. The windows are protected against overheat by sensor. We have main sensor and spare sensor. Main sensor and spare sensor to increase aircraft dispatch if the main sensor fail. Okay. Next question, everybody. Next question. I hope you enjoy this quiz and I hope you recall the Airbus A320 ice and rain protection. Okay, so the wiper system is designed to work efficiently up to 500 knots, 200 knots, or 300 knots. The right answer is the wiper system is designed to operate efficiently up to 200 knots. 200 knots. We have independent wiper for each windshield, captain windshield and first officer, and there is a selector here to select off, low or fast speed. And some aircraft do have the optional intermittent setting on this selector. This will relate the motor of the wiper with a timer. And also behind this selector we have the rain repellent switch. If the rain repellent system is installed, if the pilot or first officer press on their rain repellent switch, the rain repellent valve will open for millisecond to discharge the rain repellent fluid on the windshield. Okay, this is to allow the water to easily disperse from the windshield by the speed of the air. Okay, so again, the wiper system is designed to work efficiently up to 200 knots. 200 knots. Thank you so much. Thank you for listening, and let's continue our quiz. Question 21 of 24. The rain repellent is discharged onto the left or right windshield from a pressurized canister. Yes, and this is the canister located aft of the pilot seat. Rain repellent canister, it is pressurized. So yes, we have one rain repellent canister located in a recess in the cockpit behind the captain seat. This canister will allow the rain repellent fluid to be pressurized, and it can be easily changed from this location. Okay. Next question, everybody. Question 22 of 24. There are 3 drain masts installed on the lower fuselage forward and aft section. This statement is false because we have only 2 drain masts. Forward drain mast and aft drain mast. This drain mast allows the water from wash basin in the lavatories and the galley to be drained overboard. So this drain mast also need to be electrically heated to prevent malfunction of the drain mast and to prevent this drain mast from being used. Okay, so we have only 2 drain masts. One forward for the forward lavatories and galleys, and one aft for the aft lavatory and galley. Lavatory and galley. Okay, everybody, next question. An external visual eyes indicator with an integral lights installed between the 2 windshields. Yes, this statement is very true. This is the external visual eyes indicator, and this is the basic one for the Airbus A320 family. This is the basic one used for indicating of ice accumulation. And this is the optional one. It is an electronic ice detector. 2 electronic ice detector may be installed upon the request of the operator. They are based on the vibrating rod philosophy, and the frequency of this vibrating rod, if it is not have ice accumulated or have ice accumulated on it. Okay, everybody. So this statement is true. Yes, an external visual ice indicator. It's one located between the two windshield of the captain side and first officer. And we have optional electronic ice detector upon the request of the operator. Okay. Next question, everybody. Next one. Question 24 of 24, the last question. The ice detectors send an ice detected signal directly to the flight warning computers. Yes, this statement is true. If the optional ice detector are located or are installed, they will send ice detected signal or severe ice detected signal to the flight warning computer to be displayed on the upper ECAM. So the pilot will benefit from an ice detected caution or severe ice detected caution, and the pilot will be guided by the ECAM to switch on wing anti-ice or engine anti-ice upon the signal coming, if it is ice detected or severe ice detected. Okay, everybody, thank you very much from attending this quiz with me today. I hope you enjoy this set of questions to recall the Airbus A320 ice and rain protection system prepared for you by Haytham Aly. Please stay tuned for an upcoming sessions like this. To recall the Airbus A320 aircraft systems by a set of multiple choice questions. Thank you so much, and always fly safely and maintain your aircraft very safely. From Cairo, Egypt, your host was Haytham Aly. I will see you again. Bye bye.